Okay, welcome back. This is the 8th in our series of 7 little videos about probability. There was a little bit of confusion about using tree diagrams for probability, and so here's a little video about clarifying how tree diagrams work. And we're going to look back at the one-on-one problem we did for homework. Recall Mr. Erickson allegedly can hit 60% from the free throw line. And there's all possibilities. Here is a 0.4 chance, 40% chance he misses on his first shot, at which point nothing further happens. And that means there's 0 points, and then we have to look at what happens if he hits the first shot, which is a 60% chance, 0.6 probability. We split that rectangle into 2 parts with the second shot, and we can put in their dimensions like this so that you see a hit on the second shot is also a probability of 0.6, misses 0.4. See, the 0.6 is bigger than the 0.4. It's all perfectly to scale. And if we look at one particular outcome, in this case, getting 1 point, which is hitting the first shot, see that, and missing the second shot, the probability of that is just the area of the rectangle. The width, which is the miss of the second shot, is 0.4. The height is 0.6. The chance that you hit the first shot, 0.4 times 0.6. 4 times 6 is 24. Move the decimal point over 2. 0.24 is the probability of getting a 1. So let's recall that, and now we're going to do the whole thing again with trees. We'll move that up to the side so that we can sort of remember what we were doing with it. And now to make a tree diagram. We start by making a little line like that and another line like that, and these are our first 2 possibilities, and we're going to label these possibilities in the first shot. Hit and miss, and notice we keep track on each segment of the tree what's happening and what the probability is. So the top one, what's happening is there's a hit and the probability is 0.6. On the bottom, it's a miss, and the probability is 0.4. This will help you make sure your tree diagram actually does everything you hope it will. Now, as we're going to move on towards the second shot, one thing we'll notice is that if you have a miss, there is no second shot, and the outcome is 0. So we'll just put that there. And now we're going to start to construct the second shot. There's a chance for a second hit and a second miss, and notice I've labeled them with what's happening and with the probability. So let's see if we can figure out what the results are. The top spot is for 2, that's 2 hits. Hit followed by a miss is 1. Notice it's really easy in a tree diagram to see what the order of things is. So it's hit followed by a miss. Now we want to figure out what's the probability of that maroon 2 up there. So what you do is you follow the paths of the tree, you follow the little links all the way to get to the 2. And you see that there are 2 0.6s. So to get to the first node there, there's a 0.6 probability. And then to get to the 2, it's 0.6 of that. Now 0.6 of 0.6 is multiplication. The probability of getting a 2 is 0.6 times 0.6, 0.36. So to compute the probabilities in a tree diagram, you follow along the tree and you multiply all the probabilities together. Let's do that with the blue 1. So I do the first hit is 0.6. I do the miss is 0.4. The probability is 0.6 times 0.4, 0.24. And now just to make it all complete, let's do the bottom branch of the tree, the branch that goes to 0. There's no multiplication necessary because once you miss, there's nothing else to do, so the probability is just the probability of getting that miss, 0.4. Okay, now let's compare it to what we did before. Here's our sort of summary, 0.36, 0.24, 0.4. Notice, by the way, these 3 numbers do add up to 1. I'm going to put it off to the side, and we'll bring this one back. And let's look at the dimensions that we put on the diagram originally. And just to remind us, let's look back at number 1. The area is 0.24. The width is the width of that second shot. The height is the height of the first shot. which means the probability of 1 is 0.24. If we did this for each one of those 3 color-coded segments in the color-coded rectangles in the area model, we'd get exactly the same answers as we did with the tree diagram, which of course we have to do. So these are 2 equivalent representations of the same phenomenon. Now remember, the area model helps you look and sort of see how big the probabilities are, whereas the tree diagram lets you do more complicated things when you get more than 2 events. For example, when we did the 4 coins. That's enough for now. Good luck on the quiz. See you later.